I'm going to slide something. How's my volume? Volume's good? So about a year ago, I was approached by a headhunter for Raytheon Technologies. I was working within Defense Intelligence Agency along with Forrest. So Forrest and I met years ago, and he started asking me all these questions about BFO. And we kind of hit it off, and we built these graphs that we thought were important, and we would iterate on them. And he got more and more interested in it. And I've never seen someone learn something that fast. So go forward a little bit. Raytheon calls me completely unsolicited, and they looked at my background on LinkedIn, and they said, "Hey, we want you to do that. We want you to help us build this suite of ontologies for engineering." If you don't know, Raytheon's massive. They have 4 or 5, 6 business units. They're merging stuff now. They build aircraft, engines, ejection seats. They maintain it. So it's a huge task. It's a huge undertaking. So I'm going to have my engineering hat on here, and as I give this speech, but I also have a background in intelligence, so I'm going to try to maybe bridge those two. So here's what I'm going to go over. So I want to present an agile process. So in engineering, we don't care if you build a good ontology. It's frustrating to me because I always want to build these super duper ontologies. They don't care unless it produces almost immediate value. So that's what I'm going to say about this agile process. You'll understand what I mean as we go. So the challenge. And then I'm going to talk about how we can integrate, how I think we can integrate these consistent schemas across an enterprise like Raytheon. We have a specialization of competency questions. We call them decision support questions. They're competency questions. But in engineering, we want to build the ontology in such a way that it answers a question that shortens my decision cycle, period. Accuracy and clarity and reducing vagueness is great, but it's got to shorten our decision cycle. Then I'm going to talk a little bit about going to governance, roles, and responsibilities. I might skip over that, the discussion on locus of authority and why that's important and the problems that causes. I think that was Forrest touched on that a little bit. And that goes into authoritative sources of knowledge and how we eliminate disparate perspectives. That's the challenge, right? It's huge. And then I'm going to talk about this suite of government ontologies. This is all notional. But then I'm going to close out with maybe should have put this up front. The way we develop ontologies can be linear, right? We all have our techniques. But I want to talk about how we can make it agile so that you're getting value right away, right out of the gate. Or at least you can explain the value. I think there's value in just creating an accurate ontology, right? You get clarity, you get precision. But there's other ways to measure value too. Right? So the challenge is to develop these what we call DSQs, decision support questions. I'll show you what those are here in a little bit. What that does is it scopes the ontology, right? If I go in and I say, we're going to build an engineering ontology for all of engineering and manufacturing, my project's going to get cut that day. But if we come in with, hey, we've got this question, and I think this ontology can help you answer it, and it's going to shorten the decision cycle, now you're going to get funding, right? We're going to provide incremental value, that the ontology is going to become increasingly more valuable. And the DSQs are going to serve as a set of requirements for the ontology developers. And then the people are going to take the ontology and turn it into a platform, an application that's going to help them too. Yeah, and it helps us do these other things, balance scope, refactoring the future, and it helps us develop a timeline. Okay, so when I talk about integrating, we want to find consistent schemas across all the business units at Raytheon. Put in your enterprise. If it's intelligence, if it's defense, if it's border security, we want to find these consistent schemas. Patterns in the way the world is set up, and patterns in the way we think about the world, and patterns in the way we create data about the world, right? So in BFO, we have object aggregates. So, and those aggregates can have parts. So when we're talking about, for Raytheon, an aggregate would be a fleet of aircraft, right? Or a batch of parts. Maybe you're making circuit cards, and they come out in batches, right? Or it could, an object aggregate, be an organization within Raytheon. And when we're talking about the data that goes along with that, you got batch numbers, fleet IDs, engine numbers, organization IDs, et cetera, et cetera. So the yellow boxes are data. Now when I say it has part, I mean that generally. I'm doing mereology here. So what we really mean is the aggregate has members, right? So here, if we're talking about a batch of parts or a fleet of aircraft, it has individual aircrafts as a member of that fleet. Or an individual circuit card as a member of that batch, right? And again, material entities have parts. They have bona fide and fiat parts. So we can decompose these material entities. And these, now we're talking about, serial numbers, vehicle IDs, digital twins, et cetera, et cetera, et cetera. Right? So we care about, in engineering, we care about functions and we care about capabilities. So if you don't want capability, that's okay. We're gonna put it in ours though. Because we don't care just about what the thing's function is. We care about what is it capable of doing. So I probably should have made the chart different. I have disposition with capability in it and then function inside that. You get the idea here. And these have data associated with them, right? So we've got function codes. In all the intelligence community, we have function codes. Like, what is that building? What's its function? Slap a code on it, right? Capabilities, like if you're an organization and your organization has members and the person has skills or capabilities, we want to have requirements. You're building a taxonomy of performance events, right? Once you build that taxonomy, now you can start to associate that with back to your first DSQs. I got an aircraft with an engine, they're overheating, and now you can do that query. Show me all the engines last month that overheated or cracked. Now the value's going up again. So, right? And now this third sprint gets a little harder. Because now you want to say, okay, I got my fleet, I can account for where all the aircraft are, what they're doing. I can account for the engines, their status. Let's pull a set of our 1,000 engines, let's pull out a subset of the ones that are overheating. Let's look at those. In this third sprint, what are we going to do? What are we going to do? We got a subset of maybe 200 engines that are overheating. What kind of DSQs are we going to start asking now? Why are they overheating? Right? So maybe there's an airport with high amount of particulates, or maybe something about that spatial region, or maybe back to the pilot. Maybe the pilot's flying out of tolerance, right? So the third set of DSQs gets even more, you have to get more creative. And that's where the ontologist is working with the SME, the domain SME, who in this case would be the maintenance chief or whatever, to come up with those DSQs. And this drives everything, right? So this drives both the structure and the content of the ontologies. And that's how we build our ontologies at Raytheon. And I think that puts me at 2:30 or 3:30. 2:30. I'm done. Any questions? Yes, sir.
Just generate a lot of small ontologies, each of which has a narrow focus.
Would it do that? This would be, how would you avoid just having, yeah.
I like your linear approach on the previous slide.
I still like my linear approach. Actually, I would put the linear approach in each one of these sprints.
So is this really just building an application level ontology for specific?
Yes, because, okay, let me go up here. Right, so here's what we would be doing then. We'd have BFO and Common Core, and then we would have like the maintenance, the aircraft maintenance ontology. These are ones that do exist. We have the engine ontology, we've got the flight operations ontology. So we have these what we'll call reference layer, the domain ontologies, and then that would be down where we're gonna ask specific questions.
So you're going to pull things out of those reference ontologies and then build out of an agile event
Yes, yeah.
your application level ontology for this problem.
Okay, and yes, and back to, Mark asked this earlier, so this is where I'm getting out in front of the headlights. This is all, everything I'm about to say is aspirational. And shout out to, the Kubrick team is really driving this. They're driving all of this presentation. Getting out in front of the headlights, what would the repository look like? And in my mind, when someone goes in there and says, line replaceable unit, and if you don't know what that is, that's just like, you take this one's broken, you unplug it, and you plug this in. So it could be anything, it could be a computer, it could be anything on an aircraft that can just be plugged back in, and the old one's pulled out. So if they type in line replaceable unit, what pops up is not just a class, the definition, you get that, but you get a little snippet of the graph. This is a line replaceable unit, this is its relationship to the engine, to the aircraft, and they immediately, in that graph, can see their problem. And then they say, okay, I need that, and now I have this other thing that I care about, it pops up in another one, and then they have a whiteboard over here, and they can click and drag the classes they need. And if there's already an established relationship, it links them right there. So you pull in line replaceable unit, you pull in engine, you pull in flight, and if the relationships have already been made, it makes them for them.
These models are going to be reused because
These
they're
models,
universal.
And because
Instance data will change, but the model,
right,
the classes will be
the classes will be the same, and if there are instances, maybe that's part of the model too. I don't know.
Yeah.
But this, again, this is out in front of the headlights.
Yeah.
I don't just want a repository where you're looking, hey, cool, I got classes and taxonomies here. I want them to see it in the graph, and they can see their problem. And they're like, oh my gosh, but if I just add this, I add my content. Now, is that so now we're down here. We're using these up here to build these down here. That's the goal. Any more questions? Yes, sir.
Does it work? Yeah.
Yeah, you're good.
I have a question to your agile development. So obviously, this has been very successful in software development, this approach, but
Yeah.
there's a huge difference between ontology development and software development in the sense that in software, you have packages. You can have basically decompose your software in smaller units and test them individually. And if you are in your new sprint and you find out that the component you worked earlier doesn't do what you need to do, you just replace it by something better. Ontologies don't work like that. If you change something in your ontology, it affects the whole of the ontology. You don't have local variables, right? You don't have individual black boxes which just where you need to define input and output like in software. In ontologies, if you have a logical inconsistency, it affects everything. So how do you manage the quality problem? Because I would imagine that you would have to go quite often and redo a lot because of new requirements.
I don't think what I'm saying applies up here. I think the agile process only works down here. But you're saying it wouldn't even. You're saying you don't think it would work here.
I trust you that it works for you. I'm just asking the question how you manage the quality control, because I just see, more potential for integration issues and for.
Wait, that last part. What did say that last sentence again? You see more potential for what?
Well, for integration issues or for problems that arise if you change something later, because a change in an ontology basically can affect everything else, while a change in the software that's packaged in different modules isn't, it's not like that.
Yeah, so I think, again, the agile process, if it is to work, it's not for up here. It's for here, so that if you do make mistakes, I don't know what the cascading effects of that will be.
Oh, yeah, if we're not